Alright, in this video we're going to be talking about the quotient rule. So much like we did in the previous part where we were talking about multiplication, now we're going to talk about what happens when we divide two differential functions. So without further ado, let me just introduce the theorem. This theorem is referred to as the quotient rule. So any book that you see or any video that you watch on the internet or YouTube, you will see this referred to as the quotient rule. So the quotient, this is a theorem, the quotient of f over g of two differential functions f and g is itself differentiable. At all values of x. This should come as no surprise, for which the denominator is not equal to 0. So for which g of x is not equal to 0. Because we cannot divide by 0, so the derivative will exist so long as the denominator is not equal to 0. In addition, the derivative of f over g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the square of the denominator. And again, I swear my handwriting is much better in person. Right, so what does this mean? So if you got lost somewhere along the line, it just means this. The derivative with respect to x of a function f of x over g of x is equal to the denominator, which is g of x, times the derivative of the numerator, which is f of x, minus the numerator times the derivative of the denominator, then the bottom square. So then g of x squared. So long, again, this is important. So remember, this is for whenever the denominator is not equal to 0. So this is always true. Now, this particular formula takes a little bit more time to actually memorize and get used to it. At the end of this video, I'll give you a way that I used to memorize it. In this formula, the order matters. So this order in which it's written, it matters. And the reason why it matters is because of this negative sign in the front, in the middle here. The product rule, for the product rule, the order didn't matter. So quotient. Here, order matters. You cannot simply switch the orders of the functions. Okay? For the product rule, it didn't matter whether you did the derivative of the first function first or the second function first, because you were adding things. But because here we have a subtraction, the order absolutely matters. So let's do an example of this, so we could get our feet wet. So let's find the derivative of the following. Y equals the quotient 5x minus 2 divided by x squared plus 1. Much like in the first part of this lecture, I will always simply find what f and g are independently and then just put it together. I think it just makes your work better and it helps you catch mistakes as well. So I'm going to call f to be the numerator, so that's 5x minus 2. G of x is going to be the denominator, that's x squared plus 1. And then we could take the derivatives of them independently. So the derivative of 5x is just 5. The derivative of minus 2 is just 0. So the derivative of f of x is simply 5. And then the derivative of g of x is going to be, well, we bring down the 2. Remember, there's a 1 here, so 2 times 1 is 2. Then you minus 1 from the 2, so 2 minus 1 is 1, so this is just 2x. And then the derivative of 1 is 0, because the derivative of constant is always 0. So the derivative of g of x is 2x. Again, this is from the power rule. So let me just remind you of the power rule. The power rule is, if you have the derivative of x to the n, if you have the function f to the x to the n, then the derivative of that is just n times x to the n minus 1. Okay? And then you have f of x equals c, where c is a constant, and the derivative of x is 0. So these are facts from the previous lecture. Alright, so let's put this together to find the derivative. So y prime is going to be equal to, and the rule says, g of x times f prime of x, so this is g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Well, we now know what g of x, f prime of x are, so we could put them together. So g of x is just x squared plus 1. That's this one right here. Times f prime of x, which is just 5. You're going to see me put a lot of parentheses here, and I'm going to recommend that you put extra parentheses because of this negative sign. People make a lot of mistakes because they don't include this negative sign and they don't distribute it properly. So I suggest adding extra parentheses. In any case, f of x is 5x minus 2, so this is 5x minus 2 times g prime of x, which is just 2x. And again, notice that I'm putting extra parentheses. Divided by the denominator squared, and the denominator was just x squared plus 1. So that's just x squared plus 1 squared. So let's simplify this a little bit. I could distribute this 5. So 5 times x squared is just 5x squared. 5 times 1 is just 5. Minus from the formula. And then 5x times 2x is going to be 10x squared. And then 2x times minus 2 is going to be minus 4x. All divided by x squared plus 1. I'm not going to simplify this right away. I'm going to expand that. And you'll see that for the most part we'll never expand the denominator. We'll just leave it as that. In any case, we can actually do a little bit more simplification because now we have to distribute the negative sign into the second binomial. So that's just 5x squared plus 5. Then minus 1 times 10x squared is just minus 10x squared. And then minus 1 times minus 4x is simply plus 4x. All divided by x squared plus 1 squared. And then I believe we have like terms because we have an x squared term here. So we have minus 10x squared plus 5x squared. That's going to be minus 5x squared. We have a single x term, so that's plus 4x. And then we have the constant plus 5, all divided by x squared plus 1 squared. So this is indeed the derivative of the quotient that we had up here, 5x minus 2 divided by x squared plus 1. So that is how you use the quotient rule. The quotient rule is definitely more tricky to use than the product rule because you have to keep in mind the denominator gets squared and you have a negative sign in the middle instead of a positive sign, so you have to distribute that as well. All of the parentheses that I added are optional. I do recommend that you add them. It makes it better for you to keep track of what you're doing. Okay? It will definitely make you catch mistakes faster as well. Let's do another example. So it turns out that we could actually rewrite things rewrite the problem before taking the derivative. So this particular example is going to illustrate that. So assign the derivative and the tangent line, well, the derivative of the tangent line. Oh, that's not what I was saying. Let's find the equation of the tangent line. So the graph of f of x equals 3 minus 1 over x divided by x plus 5 at the point minus 1 and 1. It's minus 1 over x. Okay? So it is often better to rewrite functions instead of beginning to multiply right away. So what I'm going to do is I'm going to get rid of this fraction up here. That 1 over x is going to complicate our life, so instead of working with it right away, we're going to get rid of it. And how do we get rid of it? Well, I am allowed to multiply by 1. If I multiply by 1, I'm not changing the equation, because if you remember, every time you multiply by 1, you get back your same value. So like 1 times x is x, 1 times 3 is 3, and so on. Well, x over x is 1. So they're equal. So I'm allowed to actually multiply the top and the bottom of this function by x over x, because it's the same thing as multiplying by 1. That's exactly what I'm going to do. I'm going to multiply the top and bottom here by x. And what happens when I do this? Again, I'm essentially multiplying by 1. When I do this, I'm going to do the denominator first because it's the easier one. I'm going to get x squared plus 5x in the bottom. In the top, I'm going to have 3x, and then the x's are going to cancel out here. So simply minus 1. And this now makes my life much easier because notice I don't have fraction in the numerator. I just have fraction over fraction, which is the perfect scenario to use the quotient rule. So again, if I was to use the quotient rule here, then what do I have to do? I have to take the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, but now I know what the top and bottom are, what the numerator and the denominator are. So let's say f of x is 3x minus 1, and that will force g of x to be x squared plus 5x. And then the derivative of 3x minus 1, again, there's a 1 here, so you, by the power rule, you multiply the 3 times the 1 times the exponent, so that's just 3, and you take away 1. But remember, x to the 0 is 1, so essentially you're just multiplying by 1, so that's just 3 times 1 is 3. And then the derivative of a constant is just 0, so you just get 3 in the denominator. Now for g of x, there's a 1 here. Remember, always remember that we don't write it, but there's always a 1 here. So 2 times 1 is 2, and then 2 minus 1 is 1, so we have x to the power 1 is just x, so this is just 2x, plus, again, 1 here, so 1 times 5 is 5, and then 1 minus 1 is 0, so this is just 1 again, so this is just 5 times 1, which is 5, so the derivative of g is simply 2x plus 5. Now we can actually apply the quotient rule up here. So I have f prime of x is equal to g of x, which is x squared plus 5x, times f prime of x, which is 3, minus f of x, which is 3x minus 1, times the derivative of the bottom, which is 2x plus 5, divided by x plus 5x squared. Well, x squared plus 5x squared. Okay, so let's simplify a little bit. Right, so I multiply the 3, I'll distribute the 3 into the binomial, so that's going to be 3x squared plus 15x. That's this piece right here. Minus, and then we have to FOIL this. So 3x times 2x, that's just going to be 6x squared. 3x times 5, that's going to be 15x. So plus 15x. Then minus 1 times 2x is just minus 2x. And then minus 1 times 5 is just minus 5. And then again, this is all divided by x squared plus 5x squared. And then we can distribute first the negative sign and then combine like terms. So I have 3x squared plus 15x. And then let's distribute this negative sign. That's just going to mean that I will have minus 6x squared minus 15x plus 2x plus 5. Again, all divided by x squared plus 5x squared. And then finally, we combine like terms, if any. I definitely can combine this 3x squared with this 6x squared and this 15x with this minus 15x. So 15x's are going to cancel out. And then 6x squared minus 3x squared is just minus 3x squared. And then I'm left with a plus 2x, plus 2x plus 5 divided by x squared plus 5x, the whole thing squared. And that would be the solution to this problem. Now, not to this problem, but to this derivative. But now, if we go back, we were asked to find the equation of the tangent line. Remember that the derivative gives you the slope of the tangent line. So this is going to give us the slope at the input that we were given. Well, the point that we were given was at the point minus 1, 1. So to get the slope at this point, we plug in the x coordinate given into the derivative f prime of x, and whatever we get as a solution will be the slope of the tangent line. So that means that we will take f prime and evaluate it at minus 1. Which basically means f prime is up here. This is f prime, so that's just going to be minus 3 times minus 1 squared plus 2 times minus 1 plus 5 divided by negative 1 squared plus 5 times minus 1, this whole thing squared. Well, last time I checked, negative 1 squared is just 1, so minus 1 times minus 3 is minus 3, and then 2 times minus 1 is minus 2 plus 5 divided by 1 minus 5 squared. But if you notice, the numerator is going to be zeros because minus 3 and minus 2 is plus 5 is 0. So I don't care what the denominator is. I know it's not going to be 0 because it's just going to be minus 4 squared. But if the numerator is 0, then the whole thing is 0. So the derivative f prime of minus 1 is equal to 0. And now, since we know that the derivative is 0, we can actually find the equation of the line, which is going to be a constant because the slope is 0. So it's going to be a constant line, meaning a horizontal line. What we could do, we could use the slope point formula, which is y minus y1 equals m times x minus x1. We have a value for x1 and y1. So x1 and y1 is equal to the point given, which was minus 1, 1. And we have the slope, which we just found is equal to 0. So we have y minus 1 equal to 0 times x minus minus 1. This we get from the coordinate up here. This is our x, this is our y. But 0 times this whole thing is just equal to 0. So we have y equals 1. So the line that's tangent to this function, the original function we had, this fraction up here, is the line y equals 1, the constant. Okay? So that is how you use the quotient rule. Now, I want to show you one more thing. Let me do another example. when using the quotient rule and using the constant multiple rule. Now, sometimes it is easier to actually first use the constant multiple rule and then take the derivative. Like, for example, if you have something like this, like x squared plus 3x over 6, you might think that this is a quotient, and it is. You could use the quotient rule here, but I definitely do not recommend it, because it will make your work much difficult. Instead, notice that this is the same thing as if you took 1 over 6 and multiply it by x squared plus 3x. Why is this better? Because now you could simply use the constant multiple rule, because this is a constant out here and this is a polynomial. So you could take the derivative of this and then multiply it by 1 over 6 and you'll be good. Okay, so that's the y prime. If you rewrote it, so if you rewrote y as 1 over 6 times x squared plus 3x, then the derivative of y prime, is going to be 1 over 6 times the derivative of this inside stuff, which is just going to be 2x plus 3. And then you could simplify. So you're going to have 1/3 x plus, so 3 over 6 is 1/2. And then that will be your derivative. So you don't have to go and find f and g and their derivatives. The same thing is true if you were given something like this, like let's say you have another example. Let's say you have y equals minus 3 times 3x minus 2x squared over 7x. Then this looks a little bit more complicated, but in truth it really isn't, because you could rewrite this in a nice, clever way. You could notice that the x's, you'll have some cancellation with the x's here. Sorry about that. If you were to distribute that -3, you may see it better. So let's distribute it. It's going to be minus 9x plus 6x squared over 7x, right? And now, if you rewrote this as minus 9x over 7, or even you could even factor out the x if you wanted to, but I'll just rewrite it this way, plus 6x squared over 7x, then you could clearly see that this x is going to cancel out with this one, and one of this x is going to cancel out with this one. So you're going to be left with minus 9 over 7 plus 6x over 7. And then the derivative of this is actually very easy to take, because the derivative of this is going to be 0, and this is going to be just 6 over 7 as your solution, because it's just the constant multiple rule. You have 6 over 7 times x. So if you rewrite it first, then you'll see that you will not have to use the quotient rule here. Using the quotient rule can be very tricky. Right? So this is the end of this part.